Okay. Okay, here is the velocity function we have for this problem. And the first question is acceleration at a equals 3. We know by definition that the acceleration is the derivative of velocity with respect to time, and the acceleration at the time 3 is the evaluation of this velocity of this derivative at t equals 3. The derivative of this function is easy, is the derivative of -1, 0, and the derivative of the exponential is the same thing, times the derivative of the top one. So we have -1 to the 1 minus t. Now, here the point to answer questions is recall what happened with the exponential function. If you have e to the x, right? This graph is always like this, correct? So is always positive. E to the x is always positive, correct? So, and also if you have e to the negative x, also is just reverse, is always positive. E to the negative x is always positive, correct? Is what you have here. Now, something important. If this is positive, negative, the negative of e to the x is always negative, same this one. Always, correct? Or mathematically is for all x, for all x, for all x, correct? Yep. Now, you have this function here. So what is the first thing you have about the acceleration? Well, you have e to the 1 minus t. So it's like the one I have here. It's a negative number. And the exponential is always positive. So the acceleration is always negative, right? So a of t is negative for all t, correct? Bueno, vamos a ver. Now, this one. A of 3, that's algebra. So we have e to the 1 minus 3, correct? Negative. And this is negative e to the negative 2. So this is simply -1 over e squared. And because we don't have a calculator, this is going to be difficult to evaluate, correct? So this is my answer. No more. No units either. So is -1 over e squared, correct? Questions here? This is easy, right? So the first part is easy. The only I want to recall is this one. There is no calculator to see this graph, so you have to recall your old algebra, correct? So these all functions and how they behave. Okay, let's see the next question. The next question, right, is the speed of the particle increasing at time equals 3? Give a reason for your answer. Okay, now again, same as yesterday.
The acceleration is always negative.
Yeah, so if the velocity is positive and the acceleration is positive, so is increasing, correct? The speed is increasing. If the velocity is negative, the acceleration is positive, is decreasing. If the velocity is negative and the acceleration is negative, is increasing in the negative direction. And if they have negative and positive, let me see, positive, positive. No, negative, positive, me falta uno. No, está bien, right? Negative, positive. No, este mismo. Negative, negative. Ahora sí. This is positive, negative, correct? So it's decreasing. So if they have opposite signs, that this is the case, they decrease. If they have equal signs, they increase. So this is something you have to remember. Bueno, ahora sí. Al tantiómetro. At the tantiometer, as we say in Mexico. Yeah. Velocity is this v. Velocity of t is -1 plus e to 1 minus t. The acceleration is negative e now 1 minus t. Okay, and the point is at t equals 3. So we have to evaluate v of 3, negative 1 plus e to the 1 minus 3. And a of t, 3, we know is negative 1 e squared. Now, what about this one? Positive or negative? Bueno, vamos a ver. Let's just recall this one. Algebra 2 or precalculus. Negative 1 plus 1 over e squared. Because it's negative 2, so it's this one. Now, this is negative 1 plus 1 over 2.7, approximately, correct? Now, what do you think is this one? Positive or negative?
Positive.
A ver, watch out. Esto.
Oh.
¿Eh?
Negative.
A ver, esto es como 1/3, correct?
No, that's less than 1.
This is less than 1. That's correct. It's close to 1/3, it's 0.3. Vamos a poner que sea 0.3. Negative 1 plus 0.3 is negative, right? So, velocity negative. A ver, vamos a poner aquí. V of 3 negative, A of 3 negative. What is going on?
It's increasing.
Speed is increasing. And the velocity goes to the left, correct? So the particle moves to the left, speed is increasing. Everybody catch the reasoning? Yep. Questions here, part A, part B. Okay. I don't want to erase this one just in case we have to recall something. So I'm going to put another board right here. Yep. Now let's do the next question. Question Z. Find all values of t at which the particle changes direction. Justify your answer. Okay. What do you think? Change direction.
When the acceleration, when the velocity equals 0.
Yep, exactly. So, remember a graph. This is problem C. If you have the velocity, this is v of t. Yeah. Let me just put this one like this, right? Let's suppose this is the behavior of the velocity, right? So here the velocity is negative, here the velocity is positive, here the velocity is negative. So every time you cross a 0, there is a change in the direction, correct? So change direction. So the velocity positive means you move to the right, the velocity negative means you move to the left. So you have to locate the zeros to see if there is a change of direction. So the zeros. Okay, let's see. I have v of t equals negative 1 plus e 1 minus t. So we have to solve v of t equals 0. So negative 1 plus e 1 minus t equals 0. Okay, you have e to the 1 minus t equals 1. How do you solve this equation? A ver, what do you have to do?
Calculadora.
No hay calculadora. This is a no calculator problem. See?
Don't you like raise it to the log?
A ver. Yeah, exactly. Very good. Very good. So think about it. If you have, otra vez, algebra 1 window. If you have x squared equals 3, and you want to solve this equation, This function has an inverse, the square root. So you take the square root of the square both sides, correct? These two cancels, and then you have x equals positive negative square root of 3. Now, if you have e to the x, remember I told you yesterday, e to the x has an inverse, ln x. If you have ln of e to the x, you get x, right? Or e to the x of ln, oh, really this one. E to the ln x equals x. So this is the way they cancel out. So in this case, you have the exponential. So what you have to do? I
1
have
minus
to take the ln both
1.
sides, correct? Now you have to remember what is the ln of the 1. What is the log of 1?
1.
Hmm?
1.
Yeah, 1.
No. The
Zero.
ln of 1 is 0. Mhm. Remember what is the definition of log? Otra vez, algebra window.
Oh, yeah, the derivative of 1 is 0.
No, there is no derivative yet. See?
I don't see it
This
anywhere.
log in base a of x equals n. If you have the log of in any base of x, n, this means that x to the n, más bien,
A to the end.
this means that a to the n equals x. So this is the exponent. You have to raise this power to get this one. So por ejemplo, log in base 2 of 4. Okay, well, that's a 2 because 2 squared equals 4, correct? Now, if you have the log in base 3 of 1, so what power you have to raise the 3 to get a 1?
0.
0, exactly. 3 to the 0 is 1. And if you get the log in base 10 of 1, what power you have to raise the 10 to get a 1?
0.
0, exactly. So it's very important you remember these little things because between a 0 and a 1, there is going to be a difference, correct? So here, the ln of 1 is 0. You cancel the e with the ln and you get 1 minus t. So t equals 1, correct? So this is the part C. Mm-hmm.
Hey Ramirez, what did you say to get x from e? You put e to the power of ln?
A ver, otra vez, let me see. A ver. So what step? This one?
Yeah.
Okay, yes. So remember, these two cancels, you get this one by itself.
Oh, okay.
Yeah.
Mhm.
Espérate. Bueno, ya lo borré en el board, pero that's the idea. Okay. So voy a poner aquí e to the 1 minus t equals 1. ln e1 minus t equals ln of 1. 1 minus t equals 0, t equals 1. So I just moving this a little bit to the left, correct? Mhm. So at t equals 1, there is a change. So what happened before that one? Okay, the particle is moving where? So it's moving when the t is, ¿qué sería? 0, this is e to the 1. At t equals 0, this is e to the 1. This is more than this because this is like 2.7. So the particle begins moving to the right, then stops, and then go back. All the time. Because the acceleration is negative. So if the particle is doing this, it's going to stop and then goes back. Correct? And this happens in 1 second. Okay, no questions this one? Okay, last question here. So we have this one. The last is find the total distance traveled by the particle over the time interval 0, t, less or equal than 3, correct? So it's D. It's total distance. Okay. So everybody remembers, you were here yesterday, what is the formula for the total distance? So the total distance, right? The TD, total distance, is the integral of the absolute value of the velocity, correct? From, I don't know, from T0 to T1, correct?
Mhm.
Now, here is going to be the integral from 0 to 3, absolute value of 1, -1 plus e, 1 minus t dt. Okay, this is going to be a trouble. Why? Because we cannot find, we don't have a calculator, correct? Okay, now here is the point. Yeah. The absolute value. We know that this thing is positive in some moment and then negative. So we know that this is positive, right? Between 0 and 1. So let's see. B of t is positive for all the t's between 0 and 1, correct? Because we found this one. This is 0 for 1, so after that is negative. So before this one is positive, right? And then we have b of t negative for t greater than 1, correct? So what is this? How this is going to help in this case? Well, it's the same. Algebra window again. The absolute value of a number is the number when the number is positive and the negative when the negative of that number when the number is negative. So absolute value of 7 is 7, but absolute value of -7 is also negative of -7 or +7, correct? So this is the portion right here. When the a is negative, you take the negative of the negative to get the positive. So this integral, the total distance, is going to be the integral from 0 to 1 of this function, -1 plus e to the e minus t, plus the integral of from 1 to 3 right here, of the negative of these things. So you're going to have 1 minus e, 1 minus t dt. Okay, everybody catch this, right? So the absolute value is always positive. So I have to find when this is positive, when this is negative. When this is positive, I just remove the absolute value signs, like in this case, the 7, the absolute value 7. And when you have a negative, to remove the absolute value, you have to multiply times the negative, and you get a 7. So here, this is negative, so I multiply negative times a negative, positive, positive times a negative, negative. And then I have my two integrals. Bueno, muchachos, now this is your turn. What is this equals to? That's calculus, so you have to do this integral and this integral. Remember what is the calculus. You have to get the antiderivative of this, evaluating 1, minus the antiderivative of this, evaluated in 0. Antiderivative of this, 3, and 3, at the antiderivative of this in 1. A ver, voy a dar a couple of minutes to solve this, right? No? Yes? Okay. Let's see the integral. This is the integral you have to solve. The integral of -1 plus e to the negative t dt plus this integral from 0 to 1, from 1 to 3. Okay? Now, the integral of -1 is negative t. The derivative of negative t is -1. Now, you evaluate from 1 to 0. So this in 1 minus this in 0. So 1 minus 0, negative 1 minus 0. The antiderivative of this is negative e to the e to the 1 minus t. If you take this derivative, you get this back. So you evaluate from 1 to 0. So it's e to the 1 minus 1, e to the 0, e to the 1 minus 0, this one, okay? E to the 1. Okay, the next part. The antiderivative of 1 is t. Now you evaluate from t to 1, 3 minus 1. Plus this antiderivative in 3, 1 minus 3, negative 2, and 1 minus 1, 0. Now you make the numbers. Negative 1 minus 1, e to the 0 is 1, plus e to the 1 is this one, plus 2 plus this is 1, and this is e to the negative 2, or 1 over e squared minus 1. Now you see these ones here, right? You have here -1, -2, -3, plus 2. Okay, so you have -1 plus e plus 1 over e squared. You see? A strange number, right?
Strange everything.
A ver, by this time, you should not have problems with this, correct? Yeah. Yeah, because remember, there is no calculator for this one. So this is the part you have to solve by your own. Obviously, I don't know how many points are going to give for this one. If you have this part, so you break the integral, possibly you get 1 point. This one is possibly the other point. So, well, this is a long problem. This is a long solution, correct? So check what all we did for one problem. Yeah, all this portion right here, B, then C, and then the last one with this integral. Yeah, come here. Okay? Okay? A ver, question in any of these 4 parts, complaints, something? No?
No.
Everything okay? No problems, Rene? Ya se fue René. Ok.
¿Ya se fue? No, nomás está muted.
Ok. Bueno, no importa. No questions? Bueno, let's do one more for today. That's the next problem. Okay, here we have a situation. Well, this is the inverse of the trigonometric. I'm going to wait this then for when we have the inverse of the trigonometrics. Let me just go ahead at this one. This looks fine. Okay, this is a car is traveling on a straight road for a time between 0 and 24 seconds. The car's velocity in meters per second is modeled by the piecewise linear function defined by the graph above. Okay, now let me just read the graph. Okay, this is velocity. The velocity increases, but is linear. Now, in this case, the acceleration is constant. So it's certain value, constant, so the velocity increases linear. Now, then the velocity is constant. So how's the acceleration here?
Zero.
0. You can find the acceleration here is the slope of this line. Remember, if this is a linear function, the slope is the derivative of this line. So it's 20 divided by 4.
It's 5.
5. So my acceleration is 5 meters second. So this goes from 0 to 20. Now here the slope is 0, so the acceleration is 0. The car travels with constant velocity, 20 meters per second. After this point that is 16, the
-4.
the velocity decreases at a constant rate. So the slope here is 620 divided by 4 again, correct? No, 8. So this is 8, 24 minus 6. 24 minus 6 is 20 divided by 8. That's the acceleration. So everybody is reading? The particle is moving always to the right because the velocity is positive. There is no negative, so always go in this direction, correct? Never in this direction. Okay, once you read the function, we are going to answer the problem questions, okay? Okay, this one is no calculator either, okay? So we have to live with,
Esto está fácil.
in some ways easy, okay? Now,
Please.
first question, what is this find the integral, yeah, from 0 to 24, I'm going to put that one, integral from 0 to 24 of Vt dt, right? Using correct units, explain the meaning of this thing. Okay. Let's stop the sharing. Now I have this integral. Bueno, the integral is the area, correct? Now, I don't have a function, but I have this little thing. I'm going to put it back here. Can you calculate the area of that thing?
Yes. 2 triangles and a square.
Or a trapezoid, correct?
Oh,
Yeah.
yeah.
So this is a trapezoid because these two sides are parallel right here. So you add the bases, 24 plus, how much is this? 12 divided by 2 times the height. Whatever, 2 triangles or the square is the same. So let's do this one. So the area is the big base, a small base divided by 2 times height. So let me just stop here. So we can use this geometry. So the bottom base is 24 plus 16 minus 4 is 12 divided by
And that's
2
gonna be for the distance traveled.
is 20. See, that's correct. Geometrically, this is geometrically correct. The geometrical meaning of the integral is the area. So I'm going to determine that number. So this is going to be 36 divided by 2 times 20. So this is 360, and this has units. These are
Meters.
meters, correct. Okay, because it's velocity times time. That's distance, correct? Now, if dv dt equals d or x, right? Yeah, this one. Then the integral of v respect the time is distance travel. Is distance travel or displacement?
It's both.
It can't be both.
Yes and no. Acuérdense.
No, it's not. Oh.
Suppose you are here. Let me just think stupid. So the particle goes back and forth and stops here. So
No, it's
this
distance traveled.
displacement,
It's
correct?
travel distance.
This is the total distance, correct?
Yeah.
So what is this one? Displacement or distance? In this case,
I'm gonna say distance.
It's displacement.
displacement, that's correct.
Is it?
Yeah.
What is it? Displacement.
The displacement is the final distance you got after you do back and forth, correct?
Yeah, yeah, yeah.
Obviously, in this case, because it's always to the right, yes, the displacement is equal the distance traveled, correct? They are the same. In this case, because the particle we saw never goes back. So displacements and distance are the same.
Wait, no,
In-
Ramirez, it is distance porque it's always positive.
Yeah,
Wait, what?
It's distance.
He's like, yeah.
yes, because this happens. In this case, the displacement and the distance are always the same because it's moving just in one direction.
Pero yo digo que the velocity is the velocity is always positive. It's just slowing down. He doesn't turn around.
Yeah. So
Correct.
it's just distance.
Yeah. Okay.
Wait.
It's the distance travel. That's correct.
Okay.
In this case, is the distance travel. Perfect. Okay. Not a big deal, correct?
No.
It was easy. Let's see the next problem. Okay. The next question is for each of B prime 4 and B prime 20, find the value or explain why it does not exist. Indicate units of measure. Okay. Let's go to the graph. B prime of 4 and B prime of 20.
They don't
This
exist.
is the tangent line.
Yeah, the tangent line doesn't exist.
Aquí es un peak. We have a peak. So, what happened? What is your explanation in this case?
It's an instant turn or shift.
The tangent line at x equals 4 and or t equals 4 and t equals 20 does not exist due to it being a peak.
Okay. This is the point. Let me just put it right here. If you try B prime of 4 and B prime of 20, the derivative at t equals 4, t equals 20 does not exist, correct? Because function B of t has peaks, correct? And the functions are not differentiable at peaks. So the acceleration at the left and the acceleration at the right are different, okay? So it's very simple, that one. Let me just answer the next one. Let's answer the next one. This is C. Let A of t be the car's acceleration at time t in meters per second per second. For 0t, for the time from 0 to 24, write a piecewise defined function for at. Okay. That is not that difficult, but let me just sketch here the graph. This is 4, this is 16, and this is 24. So the function goes like this, and then like this. So I'm going to put this one, right? Okay, let me just share what I drew. This one. This is the BT, correct? B of t. And this is the time. Now, I'm going to put here another function, well, another graph that is going to be parallel to this. This is going to be the point 4, and this is going to be the point 16, right? And this is 24, okay? Now, if you take the derivative of this portion, what you get?
4.
4. So if this is 4, right? Your slope, the acceleration is always the same. So here you have a peak. So you have no value for the function. Then in this portion between 4 and 16, what you have?
0.
0. Okay, so I'm going to put here a little thing and then a 0, correct? So I'm going to have this line. I'm going to put a dot, thicker line, correct? What is going to happen now here? In
Negative
this one?
5.
Correct. In this case, it's negative 4. So
No, negative.
my velocity is going to be something like this, correct?
No, I think that one should be 5. The first one should be 5, no?
Oh, no, no es ¿cuánto? A ver, es 20 divided by 8, correct?
Yeah, it's 2.5, no?
20, 10, 10 over 4, correcto? Bueno, dejar negative 10 over 4, right?
Okay.
It's 2.5, negative 2.5. So it's this one.
But the,
Okay.
the one at the top, the 4, it should be 5.
It's
Not-
5? Ah, it's 5. Okay. Let's put aquí un 5. Okay, very good. So that's a 5. Okay, this is the behavior of the acceleration. So this practice to get the graph of the derivative using just criteria like this, like the slope of the tangent line, is something that we're going to practice more. But everybody caught the idea how to get this one?
Yep.
Okay.
What's
Now,
I forgot, like, what's a piecewise function?
what is a piecewise function?
Yeah.
The formal definition? Well,
yeah.
is simply that you define the function between different intervals, correct? So you have a value for the function here depending on the interval. You can have different functions that join or work together in these intervals, correct?
Like,
So piecewise function is not a big deal, but these are used very, very much because they can be separated like this one, and they may have peaks. So these are very, very used when you want to prove differentiability or continuity. You see, the acceleration is not continuous. The velocity is not differentiable, correct? So that's what happens, okay?
Okay.
Bueno, let me see what else we have to answer. Is write a piecewise defined function for AT. Okay, well, let's see. Let's write a function. So acceleration of t is 5 from 0 to 4, correct? 0 from 4 to 16, and negative 2.5 for 16 and 24, correct? So that's the function we have to write. So it's not very difficult. Okay, next
Was
problem.
that it?
Hmm?
Okay, there's another one.
Question?
No, yeah, I was just asking. That was it. No, there's another. There's part D, right?
Uh-huh.
Okay.
We finished with this.
Mhm.
Okay. Is to find the average rate of change of B over the interval 8 to 20. Does the mean value theorem guarantee a value of C for between the 8 and 20 such that B prime is equal to this average rate of change? Why or why not? Okay. This is something we have to recall. The mean value theorem. The mean value theorem, right? Oh, excuse me, this one. You see the screen, the board?
Yes.
Okay. So you have a function fx from here to here, for instance, right? From A to B. Suppose this is the function f of x is differentiable on AB. So what does it mean? F prime of x exists for all points, correct? So you get the derivative, this function exists, the derivative exists for any point between A and B. So the mean value theorem says very simple. If you take, for instance, the slope between these 2 points, there is going to be at least one point whose derivative is parallel to that secant. So this is what you have. F prime of Z equals F of B minus F of A over B minus A. What is the dotted line? Is the secant. So this is the regular slope, you know, secant. F prime is the slope of the tangent line. So you see the shape. The secant has a positive slope, like this, And then you may have, in this case, two tangents parallel to this. So C between B between A, correct? So this is the point. So everybody catch, this is the mean value theorem, MVT. But this is the condition. F of X has to be differentiable in the whole interval. So has to be soft between A and B. No peaks. Okay? No peaks. Everybody catch that? Well, let's go to the problem, to the graph of the problem. So I have this one. I start. Between 8 and 20. Okay? So the problem says, find the average rate of change of B over the interval 8 to 20. Does the mean value theorem guarantee a value of C such that B prime of C is equal to this average rate? Why or why not? Okay, I'm going to do a drawing here, pretty much sketching the situation. So I have this, this, and then this. Okay, possibly a little bit less, like right here. This is 20, this is 24, this is 4, and 8 is like right here. Okay, let me just put this one, and 20, no, this is 16. Okay, they're right here. Okay, here is. Let me just stop screen. So this is pretty much the graph, okay? This is 20 right here, correct? 20. So I know it says 20. What point is this one? F of 20. This is 8, F of 8, correct? So the mean value theorem says that F prime of Z is F of 20, in this case, minus F of 8 over 20 minus 8. But there is a condition. F of X differentiable on 8 to 20. Now, let me just better handwriting. Condition is F prime of X differentiable on AB, or in this case, A20. Question, is the function differentiable in A20? This is the secant you're going to calculate. Is there a point that you have a parallel tangent line for that? What do you think? No, yes?
No.
Yes.
Yes,
From
where?
4 and 24.
No,
No.
this is the interval.
Whole function not
It's
differentiable.
aquí. Not outside, this is the interval. I'm marking that.
Oh.
We
It's
can
over there.
we established that like part A.
What?
In part B, we said we can't differentiate at all in this whole function. So at all.
Okay, so this is the situation. The condition has to be fulfilled. F has to be differentiable. And I'll put F prime. F has to be differentiable. The situation is you have here a peak, right? It's not differentiable on every point right here. So the conclusion is MVT cannot be applied to this function, correct? V of t is not differentiable at x equals 16. Yeah, it's not differentiable, and 16 is between 20, and 8. Correct? 16 is between 8 and 20. So this is the situation. MBT cannot be applied to this function. The
You said
velocity,
because it had peaks, right?
claro, this peak.
Okay. Yeah.
In this portion, there is one peak. So the condition is f has to be differentiable in all the points between 8 and 20. But that doesn't happen. And 16, you have a peak. So MBT, mean value theorem, cannot be applied to this function. Correct?
Yeah.
That's what happens. Okay? Bueno,
Okay.
chicos. See you then tomorrow, same time, same channel.
Yes, sir.
Try to do some of these problems. Tomorrow, I'm going to begin with the back ones. So I'm going to go to the last problems I'm going to do now backward, correct? I'm going to begin with the last problem from last year and back, correcto?
Sí.
In your case, I'm expecting you continue in the same flow. So try to do the next problem, right? So we solve this one. For instance, here. Oops. Let me just share the screen with you. Share the screen. So we solve this one. So try this one or this one, right? One of them. Yeah. Your practice is important. Okay. Be safe, por favor.
Sí, igualmente.
Take care.
Nos vemos.
Ándale pues.
Bye.
Ramírez.
Bye. Suerte mañana a las 12. Bye.
Sí, ya.